In a survey of 1,000 corporations, so that's a sample size, 1,000, 250 said that they would prefer a non-smoking coworker, or they would choose someone who does not smoke. Those 250, that's a raw number of people from the sample. That's what we call an X value, the number of people that exhibit the characteristic that we're discussing. We're asked to construct a 95% confidence level, C, 0.95, for the proportion of corporations. So when you see the words confidence interval, remember 3 steps. First, a point estimate, second, margin of error, and third, the limits with the interpretation. This one usually throws students, gives them a second guess, second look, I suppose. They say, I have no standard deviation, whatever will I do? Because that's what we kind of were deciding, if we have the population standard deviation or not, and here we have none. Further examination of the thing we're trying to do, a confidence interval on the proportion, will clear up our confusion there. So let's look at the formula sheet. We definitely have one sample, so we're up here in the one sample category, but we're not estimating the mean, we're estimating the proportion. In this equation, we have only one of them, one choice, and there is no call for the standard deviation at all. So that means we made the right selection on the formula. You'll also notice that it asks for a critical value of z. So we need that z, and we need this p hat. Whatever that must be, it appears to be x over n. Remember, p hat, sample proportion, the number of people from that sample that exhibited the given characteristic. So let's copy that stuff over here. And notice that we had a formula we've just found. We decided that the error formula is to be the critical value of z times a big giant square root of p hat times 1 minus p hat divided by the sample size. We have a sample size, we have an x value. Together those things make a p hat, or the sample proportion, x over n, or in this case 250 over 1,000, or 0.25. So our point estimate, our best guess for the population proportion, is the sample proportion, p hat, which is 0.25. Using that p hat in our level of confidence, we can make the margin of error. We need a critical value for z that comes from the level of confidence of 0.95. So we'll look at the z table, or remember it's handy to look at the last column or the last row of the t table down here. We can use this guy. Where the sample size is infinity, this distribution approaches the z distribution. Our confidence level was 0.95, that's this header on the 1.64 option. WebWork, however, uses 1.65. This value is actually 1.645, so if you rounded to 2 decimal places, it should be 1.65. So let's use that guy. If you reference it on your z table, you'll see it also as 1.65. So then back here at the ranch, for this problem, we found a critical value of z to be 1.65. That makes the margin of error 1.65 times the square root of p hat, 0.25, times 1 minus p hat, or you could write 0.75 there if you want, divided by the whole sample size, 1,000. Now all this stuff has to be under the square root, so if you don't trust your calculator or the radical doesn't extend far enough for you to be convinced, you can enter those extra parentheses. I did that in my calculator and I got the value of a margin of error 0.0225935555. That's all the decimal places my calculator would show. To enter it into WebWork, enter 4 decimal places. On the exam, I'll ask you for 4 as well. 1, 2, 3, 4 is this 5. 5 looks next door to the 9. The 9 rounds the 5 up to a 6. So we'll enter 0.0226. Now, just because that's what I entered and was accepted, don't use that guide to cook up the lower limits. Use the actual value you found before. The lower limit is the point estimate, 0.25, minus this margin of error. all of it for accuracy. I got 0.22740644445. You may not have to write all of those down, but again, remember we want to go to the 4th decimal place, so at least maybe write down 5 decimal places so you can make the decision. I don't care what happens after the next place. We look only to the right. 0 is 0, doesn't do anything to the 4, so the lower limit is 0.2274. And similarly with the addition, the upper limit 0.25 plus 0.0225935555 gave 0.2725935555. 4 decimal places are right here. 5 looks next door. 9 is big. 9 rounds that guy up to a 6. So 0.2726 for the upper limit. That means that in conclusion, we are 95% confident that the true proportion of people who would prefer a non-smoking candidate is between 0.2274 and 0.2726.